Hi again, everyone. Welcome back to our course in college algebra. As I mentioned at the very beginning of the course, this class is all about functions. And the main reason to study functions is that functions help us describe the world. Functions describe the world. So I thought I would do a quick application of a quadratic function. So let's just say we are kind of given this information. We know that the height of a golf ball t seconds after being hit is given by this formula. Now, if you go on to take calculus, you'll understand why the formula looks this way, or maybe a physics course. They might also discuss it there. But in a way, we can kind of see what's going on, right? You hit a golf ball, it starts to rise, it reaches an apex, and then it comes back down. Okay, and we can see this is a quadratic function based on looking at that right there. Lead coefficient is negative, so it is a U-shape opening down. So it's at least plausible based on what we know from this course. Okay, so let's look at a couple of questions that we can answer based on knowing this function. How high is the ball after 2 seconds? Okay, well, remember a function takes an input value, gives you an output value. This function takes an input value of time, and the output value it gives, using this recipe, is the height of the ball at that time. So input time, output height. So this is just a matter of finding h of 2. And if we go back to the beginning of the class, you'll remember I recommended thinking about the function notation like this. Think of it like blanks. Whatever you put in the blank over here on the left side automatically pops up in the blank on the right side. Okay, so 2 squared is 4. 16 times 4 is 64. So that's negative 64 right there. Okay, 96 times 2. Well, 100 times 2 is 200, but I got to back it away a little bit. I got to back it away 8, so I think it's 198. Okay. So, let me see. Let me do the arithmetic here, finish it off. This is 134 feet. Okay, that golf ball got hit pretty hard to go that high, but it's a towering drive. Okay, so let's look at this here. What is the maximum height of the golf ball? Okay, well, as we just discussed, this is a quadratic function. Its graph is U-shaped, like all quadratic functions are. Lead coefficient is negative, so it's a U-shape opening down. So the highest point on the graph will be at the vertex. Okay, you want to find the height, the max height. Find the vertex of this quadratic function. And we have a fancy formula for that, or we have a very convenient formula for that. We take negative b over 2a, so negative b is negative 96 over 2 times negative 16. Gosh, I think this works out to be 3, right? 2 times 16, of course, is 32. 96 divided by 32 is 3. They're both negative, so the result would be there. And then we take this value and we plug it into the function to compute the y value. Okay, so this part of the recipe gives you the x-coordinate of the vertex. And on the graph, the x-coordinates are the inputs to the function. So this is telling me that the maximum height happens at 3 seconds. To find the maximum height, I would take this input value and plug it into the function's formula. I was actually calling it h, not f. Okay, and then we do a computation. So negative 16 times 3 squared plus 96 times 3 So, what is happening there? So 3 squared is 9. 16 times 9, okay, let's do 160 and let's back it off by 16. 160, 154. So negative 154. Okay, 3 times 100 would be 300, but we don't want to go that high. Let's back it off by 3 copies of 4, so 288. Okay, so that actually gives us 144. Okay, so that's the maximum height of the golf ball, 144 feet. So between 2 seconds and 3 seconds it rose, 10 feet more, and then it's going to start to drop after that. Okay, now, last question. When does the ball hit the ground? Okay, so this boils down to solving an equation. Okay, so I want you to notice a few things about the process involved here. When we had the time given to us, and we wanted to find the height, we take that time value and plug it into the function. Okay, because that's what the function does. It takes a time value, gives a height. When does the ball hit the ground? Well, we know the height. It might not sound like we do, but we do. How high is the ground? Well, of course, I guess it's implied that when we're measuring the height above the ground. So when does the ball hit the ground? Well, we know that we want the height to be 0. We want the ball to be on the ground. So the height is 0. What's the time? Okay, so we got to find the input that will produce a desired output. So we solve this equation, negative 16t squared plus 96t equals 0. This factors, okay, you can factor out a negative 16t from this first term. 96, it turns out, is divisible by 16. Take on your calculator, 96 divided by 16, you get 6. The other factor is t minus 6. Okay, why did that change to a negative? Well, I factored out a negative 16. So if I were to distribute back, I need that to turn positive, so this has to be a negative there. Okay, so there are actually 2 solutions to the equation. We get those by setting each of the factors individually equal to 0. If you take this factor and set it equal to 0, you get t equals 0. So the ball is on the ground when we start, which makes sense because that's when you hit the ball. Okay, the model applies t seconds after the ball is hit. So at t equals 0, the ball has just been hit. And the other solution is t equals 6. So that's after the ball rises, reaches its maximum height of 144 feet, and comes back down after 6 seconds. Okay, so we kind of did all the stuff we've done with quadratic functions. We did some inputs and outputs. We found the vertex. We solved an equation to deal with this application. Okay, so those are all pieces of a puzzle in extracting useful information from these functions. And that's what the game is all about. That's why functions are such a helpful tool, and that's why we have a whole course devoted to studying functions.